Computer Science and Engineering Colloquia features accessible talks by leading computer scientists and computer engineers from across the region and around the world.
Good afternoon. So welcome to the CSE Colloquium. So today it's my pleasure to introduce Chinmay Kulkarni, who is a PhD student finishing up his degree in computer science at Stanford University. So I was actually lucky enough to collaborate with Chinmay on a project a few years back. And one of the things I've learned is that Chinmay has a really impressive skill set that ranges from core technical skills on one hand to experimental design and analysis on the other, all the way to drawing really interesting and motivating insights from psychology and educational theory. And so today, Chinmay will share some of those skills with us and how he's applied them in building new systems and technologies for supporting massive online learning. And we'll get to see some examples of that, including systems that have been deployed to benefit learners, in fact, over 100,000 learners on platforms such as Coursera and edX. So welcome, Chinmay.
Thank you, Jeff. I'm so very excited to be here. And today, what I want to talk to you about is how we can draw on classroom techniques for teaching, especially in creative domains, and then create systems which scale them out to tens of thousands of people online. And over the last 2 years, you've seen, as Jeff mentioned, how millions of students have enrolled in massive online classes. And to me, what the student interest shows, above all, is this enormous thirst for learning and knowledge. And as universities, we've been good at meeting the needs of the college demographic when it comes to learning. But what these classes have shown us is that there's actually a huge population out there which are not traditional college students. So if you look at the enrollment data, this is enrollment data from the HCI class taught online on the Coursera platform. You see that undergraduate and graduate students are just under a fifth of the total enrollment in the class. And in fact, a large majority of these students are people who you would not expect to see in an in-person classroom. So now that we have the means and the opportunity to reach this enormously broad population, the question to me is, how do we teach these thousands of new learners effectively? And in this talk, I want to argue that there are 3 ingredients that are central to learning, and we see these consistently across domains in engineering, in design, art, and everywhere else in the university, that we need to scale to these online environments. These are also 3 teaching processes which are difficult to scale because they rely on personal interactions. And traditionally, they have relied on staff expertise to foster these interactions. So the first of these ingredients is feedback on open-ended work. Whether you're in an art class and you're creating many, many, many sketches, or whether you're in a programming class where a crucial step in learning how to program is writing your own program, the crucial step here is getting feedback on such work. But giving feedback on open-ended work requires expertise. And if we did what we do in an in-person class, say if you take what we do in the introductory programming class at Stanford, and gave feedback the same way to an online class, it would take around 3.5 man-months of effort every week to give students feedback, right? So that is the first of the 3 things that we need to scale. The second is interactions with people who have perspectives that are different from your own. So this could take the form of a Model United Nations in a high school class, or it could take the form of, say, a design critique in an undergraduate design class. What is core to both of these is that students are talking to people who have opinions and perspectives that are different from their own. And by talking to such people, they can start to question their own implicit assumptions and gain a deeper understanding of the topics they're taught. But people don't naturally gravitate to other people who think differently from themselves. We all want to talk to people who think just like ourselves, right? So what staff do in in-person contexts is foster these interactions. And institutions can do so by creating new dorms where people live together, or you can create project teams with diverse partners. But again, this is something that is difficult to scale to large online classes where staff don't have that amount of interaction. To demonstrate the last ingredient that I feel we should scale, I want to go back to the sketch. This was a sketch created by Pablo Picasso. And 200 revisions later, it became his famous painting, Demoiselles d'Avignon, one of his most celebrated works. And what you see in this is the core importance of revision to gaining mastery. We all want our students to gain mastery in very open-ended creative domains, but doing so is effortful. And to actually revise, you need meaningful feedback, and you need rapid feedback. So in an in-person context, we've relied either on personal attention in a small classroom, or we've relied on coaches to give students this feedback. This is something else that is hard to scale, but is necessary. So I've talked about 3 ingredients that I believe we need to scale to the massive online class to teach students effectively some of the most interesting and important topics they are taught today. And in the rest of my talk, I want to speak about 3 systems that I've built as part of my dissertation that target each of these 3 processes. In building these systems, my consistent approach is to take what we know in the in-person classroom, what we know from learning theory and psychology, for instance, and then build systems that scale out these techniques to large online contexts by using techniques from human-centered design and social computing. All of the systems that I'm describing today have been validated at scale in large online classes through randomized controlled trials. Through my dissertation, I've run more than 40 controlled experiments in online classes. But today in this talk, I'm going to describe results from a dozen or so experiments run in classes taught by these universities. As I was building these tools, it also became apparent that tools that we build for large scale are also valuable at universities. So at the end of my talk, I also want to speak about how in-person classes at these universities have started to use some of my tools. So the first system that I want to describe to you is one on global peer assessment. And the impetus for the system came about around 3 years ago when Daphne Korer, then a colleague at Stanford, of course, and now the CEO at Coursera, came to my advisor, Scott Clemmer, and I, and said, you teach this wonderful introductory HCI class at Stanford. How can we scale it up so anybody on the internet could enroll? Right? And then we realized, as we thought through this idea, that the crucial aspect that's hard to scale in the online environment is not instruction, but assessment. At the time we started, most online classes had either simple multiple choice style questions, or they had completely automated assessment. So for instance, if you were in a machine learning or programming language class, you would write a piece of code, you would upload it to a server, and then the server would run automated tests on it, unit tests or static analyses, and then it would return you a report which said, here's what you got right, here's what you got wrong. And that works well when you can express programmatically what are the criteria of quality, when you can write unit tests, or when you can have test data sets. But it's less clear how that would work for assessing open-ended work. So here, for instance, is a sketch, a storyboard of a student describing how someone might use an application he plans to create in an introductory HCI class. In this case, the application helps people book a doctor's appointment. Right? In order to assess this kind of work, you not only need to be able to interpret the sketch, but you also need to know real-world facts, such as people want to meet their doctors as soon as possible. Right? Encoding such facts into a completely automated system is challenging, but thankfully, all of us here have acquired this real-world knowledge over many years. So we thought, well, the one thing that definitely scales with the size of the classroom is the number of students in it. So if we ask students to assess each other's work, then they can do so at constant workload, regardless of the size of the class. But of course, there's a problem with saying that, which is that students lack the broad expertise that staff bring to the table when they're assessing work. So the insight that our system embodies is one of scaffolding micro-expertise. It is saying that, yes, students lack the broad expertise of staff, but in a constrained setting, they can follow staff-articulated assessment processes such that they can assess like staff. Okay? And to me, as a computer scientist, the way I look at this is we want to create design patterns for assessment that work at scale. And we are still at the very early stages of doing that. We want patterns that work reliably and at large scale. And here's one candidate design pattern. We can provide students a rubric for how they should assess a certain open-ended piece of work. And then we can ask them to assess 5 of their classmates. Once they're done, we can ask them to reflect on their own work using the same rubric. Here's how it would look like in an interface. you have this piece of the storyboard here. And so you have this rubric where you can mark off how well you think the student work is on each of these dimensions. And say you can add in brief optional comments. Okay? So this is how it would look like in an interface. One way of measuring whether this works accurately is to compare the grades that students gave themselves in the second part to the grades that other people gave them. In a perfect world where you had the same standard that was being applied by everybody, both of these measures would correlate perfectly. Okay? Now, I'm going to show you a plot of the grades students gave themselves on the x-axis and the grades other people gave them on the y-axis. This is how the data looked, right? And you can see that, well, it doesn't do quite very well. There is almost no, oh, by the way, this is actual data. This is not a matrix on which I'm going to show you the data. This is data, right? So very low correlation. Okay, so how can we improve this design pattern? We can add, for instance, a training step. And here, what we can do is staff assess a small subset of student submissions, and they give them grades. We take those student submissions, show them to students without the grades, ask them to grade independently of staff. When students input their assessment, we can give them feedback as to how accurate they were, whether they graded too high or too low. And we can repeat this process over a number of student submissions until we are satisfied that students are grading similarly enough to staff. Okay? And then we can just tack on what we did before. You grade, say, 5 other people. Your grade in this system is a median of grades that other people give you. You can obviously use other aggregation mechanisms. And then you reflect on your own work and assess yourself using the same rubric. Okay, so I showed you before. This was how our correlation was without this training. Tried in a different class, and now we see much better correlation between self-grades and the grades that other people gave you. Now, I know at this point you're saying, all this is great, but how well do students correlate with staff, right? That is what you want as a better measure of accuracy. So we wanted to find out that as well. So what we did was one of the submissions, can I point? I can't point. Well, you can see that. One of the submissions that students were asked to grade was assessed by staff beforehand. We did not tell students which of their submissions was assessed by staff, and we did not mark these differently in the interface. But what this allows us to do is to get a data set where you have a small number of staff submissions, and each of these have a large number of student assessments. Okay? Over the duration of this HCI class, we collected around 100 of such submissions with 160 assessments each. Then we can run a bootstrap simulation by taking some of these peer assessments each time and comparing it with the staff grades. And we can do this for the entirety of the course. And we can see, do students give the right pass-fail outcome? And all of these, this class, for instance, was pass-fail. So you want to know if we pass the right people. Okay? And there's 2 aspects of it. One is, if staff had graded a student and they would not have gotten a certificate, do they get a certificate with peer assessment? And we see that 99.3% of the time, they don't get a certificate. 0.7% of students slip through, in a sense, and get a certificate when staff would not have awarded them one. Okay? The second aspect is, if you had earned a certificate, if you had been graded by staff, do your peers give you that certificate? Okay? And now you see 97.8% of students get the certificate when they would have been assessed by staff, and 2.2% don't. I think these numbers are good, but of course, we can improve them. One way we've seen to improve these is by iterative improvement of the rubrics. Another way is to give feedback to students about how they're grading. And the third way is to combine machine learning models with peer assessment in order to improve accuracy. I'm not going to describe any of them in this talk today, but I'll show you references so you can go look. Okay. We can also see how peers and staff agree on a single assignment, not instead of, yeah?
On the previous slide, there was this little caveat at the bottom. Can you explain that?
Yeah, as I said, we ran a bootstrap simulation in order to estimate how it would work for the rest of the class.
So you have no real knowledge of whether, I mean, you know, we all do grading here.
Uh-huh.
students don't do evenly over the course of the quarter.
Okay.
So I don't understand how you can bootstrap one experiment to say how.
So we took samples across the entire class, and it's a large enough data set that I think we can do this. But if you want the details of the bootstrap simulation, I'm happy to discuss them offline. Thanks. All right. So another way of looking at it is how well do they do on a per assignment basis. And when we asked 2 staff members to assess the same submission, we got grades which are not exactly the same, which is as should be because this is open-ended work. On average, the difference between 2 staff grades for the same assignment was 6.7%. And we see that 47% of the class had grades within that staff variation band. So essentially, half the class got grades which were indistinguishable from what they would have if they had been assessed by staff. Now, this evaluation tells you how well it works in general. There is also one particular problem with using rubrics for assessment. And this is what the student wrote to us about. When you use a rubric, students who have particularly creative work may be penalized. And he puts it really eloquently, too. OK. So this student has a point. And we addressed that by adding a checkbox at the end of each assessment form, which said, this is an exceptional assignment, which gives us both a data set to see where the rubric fails, as well as a way to improve our rubrics over time. All right. So as I said before, this large-scale peer assessment process was piloted in the HCI class. And we've had more than 100,000 students use it on the Coursera platform in many, many, many classes. One huge benefit of peer assessment that we've seen across classes is the inspirational benefits of working in a global classroom. These are 2 examples that are pulled from the Introduction to Art class from one assignment. And on the left is a painting of the Northern Lights by a student in Norway. On the right is installation art by a Canadian Armenian student using traditional Armenian pottery. Right? Students who look at examples like this often say, I've never seen something like that. But we also see a negative aspect of this global diversity. We've noticed, for instance, that even though grading is double-blind, students tend to give other classmates from their own country grades which are just a little bit higher, 4% higher than grades they give to students from other countries. And like all the results that I'm showing in this talk, this is statistically significant at the 0.05 level. So this asks the question, well, we have global diversity, but it can be both an asset as well as a risk. And we'll come back to this question in a future section of the talk. But for now, this is a global peer assessment process, which yields assessment which is both accurate and inspirational through creating this notion of micro-expertise. And global diversity is an asset and risk. As I said, in follow-on work, we've seen how to combine machine learning models with peer assessment. And you can see that in this paper here. OK. Now, to get back to this diversity, yes, Dan?
So having used your system,
yeah.
my belief that I have not tried to substantiate is that students who do assessments also master the material better themselves.
Yeah.
Is that something that you or others have studied? Or is that
there is prior work on that in the in-person context. We haven't run a large-scale empirical evaluation yet. But yes, anecdotally and from student responses, we do think that that is the case in the large online context. OK. All right, so in this section, I want to speak about, I spoke how diversity can be both an asset and a risk. Now I want to talk about how you can use diversity as a design opportunity. And in particular, I want to describe a system for creating small group but global discussions in these online classes. So why diversity? We were motivated by 2 important benefits of diversity. One of them is simply the informational benefit. Students from around the world have very different professional experiences. They grew up through different educational systems. And they have different cultural values. And talking to them gives you a flavor of such experiences and knowledge. A second benefit is a cognitive benefit. So if you're talking with people just like you can slip into a passive and automatic mode of thinking. But if you're speaking with people who are unlike you, you have to be more effortful and conscious, a mode of thinking which leads you to start questioning assumptions and get a deeper understanding of what you're being taught. But these are great benefits of diversity, but most students are also very unlikely to see them. Right? These are forum posts from one online class, the Learning How to Learn class. And you can see you have students who are looking for other Indians, Romanians, or Japanese people, people who are like themselves, who they want to work with. And this isn't a problem which is unique to large online settings. We've seen it in in-person classes as well. Project groups form with people who are your closest friends. And as teachers and institutions, we have tried to address this problem by creating institutional opportunities for diverse people to work together, like creating dorms or cross-ability project teams. So what does the online version of a dorm look like? And to find out, we built a system. It's called Talk About. And the way it works is students who enroll in an online class come to this website, and they choose a time when they're willing to speak with their global classmates. Then, when they arrive for a discussion, Talk About automatically groups them with 5 or 6 other students from all around the world. Okay? The important design decision here is students get to choose a time when they're willing to speak with others, but not whom they're going to speak with. That allows us to make these decisions in an algorithmic fashion. In particular, we use this simple greedy algorithm, and it's constrained by the size of the group. And the way it works is when students arrive for a discussion, they are assigned to one of many parallel groups. We assign students to groups where they optimize instructor-provided metrics for diversity, such as gender balance or the country of residence. Okay? So here's the algorithm, and here's an interview with a participant who participated in one of the talkabouts, one of the classes that used Talk About. This is Lex. He lives in Australia, and he took the organizational analysis class. And as he speaks, you can see how he meets people from different parts of the world in different organizations.
It's very flexible. You get people from Ukraine, from India, from Swiss, from South Africa. They're coming all together in a very open way. The first time there was also a lady from Australia, and she was working in the gambling industry. She was very evocative and very, she was very bright. There was this guy from China as well. That was really, he worked in Geneva for the United Nations, completely over-frustrated by bureaucracy. When you meet all those people from over the whole world and coming together and discussing the same theories, that's really exciting.
Right, so that was Lex. And lots of students have experiences just like Lex. In fact, if you look at discussion data from the more than 600 discussions that you hosted, you see that the median distance between participants is 4,000 miles, which is more than a distance between New York and London. And the median number of countries that was represented in each 6-person discussion was 5. Students also seem to really enjoy these discussions. Instructors often create a discussion, in this graph, all of them, where the recommended duration of discussion was 30 minutes. So they would give the students a number of topics, ask them to choose a small subset of those topics so they could discuss for 30 minutes. And we see that the median discussion duration was actually 58 minutes, where students chose to discuss topics which are marked as optional, for instance. So students have diverse discussions. They seem to talk for longer than we ask them to. As a scientist, I'm curious about the benefits of these discussions from an educational point. So in particular, I want to ask 2 questions. Yes, yeah.
How does this overcome the difference in time zones? Because I imagine everyone in Europe would want to have a...
Yeah, I thought so too. And then I looked at the data, and it turns out that times between 8 a.m. and midnight are uniformly preferred in the same time zone. So if you have local times between 8 a.m. and midnight, people just choose those somewhat uniformly. It's only midnight to 8 a.m. that people are less likely to choose. So actually, it turns out that people are willing to discuss throughout the day. I can show you a plot after the talk to give you more data about that. Thanks. OK, so we would like to see if these discussions improve course outcomes. And we'd also like to see if the global diversity in these discussions amplifies the benefits of participation. So to answer the first participation question, we ran a randomized control experiment in the irrational behavior class by Dan O'Reilly, and it had around 1,000 students. And the dependent variable in this was the total grade that students would get in the class. So this experiment had two conditions. It was a between subjects experiment. And in the discussion conditions, students would come onto the website, choose a time, and they would participate in the discussion throughout the class. Okay? In the waitlist condition, let's say if Jeff was assigned to the waitlist condition, he would come onto the site, he would say, pick a time, but then we would tell Jeff, Talk About isn't ready for you yet. Come back 4 weeks later. Sorry, Jeff. So what that does is we have an experimental setup where students who are equally motivated, like Jeff, are prevented from participating for the first half of class. And there's a different set of students who are allowed to participate. Now, comparing these two gives us a measure of how much participation in these discussions helps. And we find that for the total course grade, students assigned to the discussion condition scored 6% higher than students who were assigned to a waitlist condition. Sorry, Jeff. OK, so here you see students are scoring approximately a fractional grade higher. And you could say, yes, this is something that we would expect because they're spending more time on task. So in the next experiment, we want to look at whether diversity amplifies these benefits. Yes?
So why didn't you just do a randomized study?
Why didn't I randomize what?
In particular, you're making a claim about diversity, and then you're doing this randomized study that assigned.
Right. So the first study only looked at the benefits of participation in a discussion, regardless of diversity. We're coming to the diversity thing right now. Okay. So yeah. So does diversity amplify the benefits? And to find out, we ran a second randomized experiment. This was in the social psychology class. 2,500 students approximately. And this was a quasi-experiment. So usually we assign students to a discussion group which we believe improves the diversity of the group. In this case, we just assigned them to the first discussion group that was available. So some students got a discussion group with people from many different places. Others got a discussion group where everybody was from the same country. So as a measure for how well students did in the class, we looked at the final exam, which occurred a week after these discussions. Also, since these discussions happened at the very end of the course, we also wanted to control for how well students were doing already in the class. So we included the prior course grades as a covariate in our analysis. OK, so here's how the data looks. On the y-axis is a difference in average grades among students who are assigned to the most diverse discussion group, where everybody was from a different country, and the minimally diverse group, where everybody was from the same country. In the social psychology class, we saw that students assigned to the most diverse discussion groups had grades 2.4% higher than students who were assigned to the least diverse discussion groups. We ran a follow-on experiment which replicated this in the organizational analysis class, this time on weekly quizzes. So students would participate in a discussion, then participate in a weekly quiz. And we saw that students who were assigned to more diverse discussion groups did 3.6% higher. Yes, Jeff?
Curious, do you think this has something to do with the nature of the courses as well? I mean, one
Yeah,
could at least
yeah,
make
you're
an
right.
argument speculatively that social psychology and organizational analysis would benefit perhaps even more from cross-cultural perspectives than, say, like a number theory class.
Yeah, you're right. So actually, this is good because I am told this is televised. So if you are running a class which is teaching number theory or finite automata theory, I want to use your class to run this experiment again. So far, we have had people who have used this in classes where they think it would help, because this is dependent on instructors. But if you're running such a class, please talk to me after the talk. OK, so here we are talking about two evaluation goals. And we can say that diversity amplifies the benefits of participation in these discussions. And you also know that these diversity amplifications are essentially for the same curriculum. So we could see if you design a curriculum which was better, then you could have even larger improvements. Dan?
Oh, I was just going to ask whether you had a sense about these small group discussions having any effect on the rate which people are dropping out of the class.
Yeah, so we see that over the short term, they improve retention. So if you take part in a discussion today, if you're assigned to a discussion condition today, then you're likely more likely to participate for the next week. So it's a short-term effect, but it does exist. Yeah. OK. So yeah, so you see that diversity amplifies the benefits. But again, with all of these online systems, I must say that there's still a very long way to go. And connectivity and infrastructure are still problematic in many parts of the world. This is Mai Jamal. She emailed me last August amidst the chaos and the uprisings in Egypt then. And you can see how committed she is to participating in these online classes. And I think we should do more to support these students. One emergent effect that we saw with Talk About is students using it as a springboard for longer-term social ties. Across 9 classes, we asked students in a post-discussion survey if they shared contact information with their group mates, and around 47% of them did. And some classes have almost everybody sharing contact information. So we went in and asked, why do you share your contact information? And this is what a student in the human rights class said. It's because they want to create a strong social network to engage about these issues, and they're using this as a springboard to get that social network. Another emergent effect with around 5,000 students using Talk About is the fact that these students are giving back to the system. So students have now translated the Talk About website into French and Spanish voluntarily and sent me pull requests. So very happy with that. So OK, again, in the section I spoke about Talk About, which was a system which uses diversity as a computational asset to improve educational outcomes. And it also builds social ties in these large online contexts. Like most of my code, this is open source. And we also host a version of this at this URL, which you're welcome to use if you're running an online class. I did not talk about how you can structure these discussions even further for specific learning goals. For instance, if you want to improve the empathy in your class, what do you do? And we have an upcoming poster at Learning at Scale which speaks about that. OK, so in the last section of this talk today, I want to talk about a system called Peer Studio, which uses scale as an asset. So we spoke about how you can use diversity as an asset. Now we want to see how you can use scale as a design opportunity. And in particular, I want to use it as a design opportunity for the problem we spoke about before, giving feedback for mastery and for revision. We see that revision is really central to how we think about the creative enterprise. This is James Dyson. He talks about how it took him 5,000 odd prototypes in 15 years of his life to create the Cyclone vacuum cleaner. Right? And this isn't an uncommon story. And we also know this from the educational literature. So this is Anders Ericsson. And he speaks about how to engage in deliberate practice, students should perform the same or similar tasks repeatedly and get feedback, immediate informative feedback that helps them improve their performance. And to be sure, we've had many educational opportunities over many years which use this idea. So this is the design studio, which for the last 200 years, yes, we have invented color photography, but it's remained a central part of how we can do revision and peer feedback in the in-person classroom. But studios are small-scale opportunities. You can have 50 students, maybe 100 students who participate. How could we create a massive scale studio where anybody on the internet could participate? And in particular, how can we provide all of those people on-demand and immediate feedback on open-ended work? So I built this system called Peer Studio, which aims to address that. And the way it works is students submit their peer work, their open-ended work for feedback, say essays or say designs or visualizations, and then they give feedback to 2 other people immediately. And once they're done giving feedback to their peers, they immediately have feedback on their own work. Then they can use this feedback and repeat this process any number of times, this revision cycle any number of times, until they're happy with their work and want to submit it for grades. OK, if you want to do this, one way of doing it is to take the peer assessment system I described in the first section of this talk and to flip a bit, which says you can submit multiple times for the same assignment, and you can just allow people to revise. But there's a problem. And I talked about how assessment training is critical. It also is very time-consuming. So in an HCI class where you had students work for around 10.5 hours on their own work, training for assessment took approximately 2 hours, right? So this is a huge cost to pay, and it's a necessary cost to pay if you want accurate assessment. But if you want fast, early feedback, then this can be a huge bottleneck. So the research question to us is, how can we scaffold this idea of micro-expertise for assessment without having an explicit training step? And to create such a system, we turn to the principle of contrasting cases. So the idea is, for instance, if Jeff handed me a glass of wine and asked me to describe it, I would say, this is a glass of wine. It tastes like wine. I don't know much about wine. But on the other hand, if he gave me 2 glasses of wine, different wines, and asked me to compare them, then I can tell him, oh, this one is more floral. This one is fruitier. This one smells like pencil shavings, right? So what giving me 2 cases to contrast with each other has done is enabled me to see the deeper structure in these 2 cases, right? So now I know there are attributes like floralness or being fruity, which are attributes of wine. So this is how we implemented this idea into an interface. This is the feedback. This is the student work that we want people to give feedback on. And we augment it with a rubric, as you saw in the previous section. But we also augment it with an example of excellent work that a teacher, an instructor in this case, has picked out. So the job of the student is to go through the rubric and for each item compare student work with instructor-provided example of excellent work, and then mark the rubric. It isn't immediately clear that you can do this for multiple student submissions, but one instructor-provided example, right? Because you may not be able to reveal new structure for each of them. But it turns out we tried this in an online class, and the majority of peers agree with the staff assessment for a large fraction. And in fact, the average difference between the grades that students give and staff give is 5.7%. So this is contrasting cases leveraging interface, and it requires no training. So combining this with the scale of the online class can help you recruit reviewers quickly and get fast reviews. So the way this works in a peer studio system is, if you live in a particularly popular time zone, then we just ask the next student who's going to come up next few minutes to review your work. Okay, that's the easy case. And we also, if you're living in a time, if you submit your assignment at a time when there's few people online, then we start emailing people who have submitted recently, and we stop immediately the moment we find a reviewer. This is a conservative algorithm, and overall, we need to email people less than 30% of the time in a large class. How well does it work? We used it in a large online class, the Learning How to Learn class. And here is a histogram of response times to the first review. You see that a very large fraction of students get feedback within 10 minutes of submission. And less than 4% of students have to wait for longer than 24 hours to get feedback. So here's what the median time to feedback here is 20 minutes. So here's what the journey of the median student would look like. They come to the website. There's an editor. They write their essays by filling in a template. They submit that essay. We start ticking a clock. They give feedback using this interface you've seen before to 2 of their classmates. In practice, we saw that people spent around 9 minutes giving feedback on the median time to feedback was 9 minutes. And so 18 minutes later, they've done that. And in 20 minutes, they have feedback on their own work, right? So this is how feedback looks like in our system. And students can repeat this process any number of times until they're happy with the work that they've created. And finally, when they're done, they can submit it for feedback. OK, this worked in the sense that students got fast feedback. They got accurate feedback. We were very happy. And then we realized there was this one small problem. Yeah, do you know the problem?
Maybe that people copy.
No, that actually wasn't that wasn't quite as common as you think. In fact, we saw only 2 or 3 cases by the time we wrote the paper. I'll come back to that question after the talk, but yeah, hold on to that. The problem that we discovered was that accurate feedback is not always actionable feedback, right? Here is a professional teacher who is giving a student feedback on an essay about the Super Bowl. And even if you can't read what she's written, you know that it's pretty heavily marked up. And in fact, even the first line, she says things like, be more precise, be less wordy, you need a comma here. So you might think that essentially this essay is mostly there. It needs a few grammatical changes, and then you're done. But then you see the margin, and she says, you need to do more research. Right? So essentially, with a stroke, she has nullified all of the fine-grained comments she has given. And it also sends a mixed signal to the students. Am I supposed to fix grammar, or should I restart? Right? So what we would like to do is to create a system where every student gets feedback that is appropriate at every step of the way. We know how we could approach this issue by, again, looking at learning literature, which talks about how correctness feedback and velocity feedback is useful. So giving students feedback on what they've done right and which way they should move is valuable. It's also valuable to give feedback that is specific instead of giving general ideas of what is good work. We embodied these concepts in a hinting system. So as students write comments, we start hinting at what kinds of comments they should write. We also used a logistic regression model to find out what is actually topic relevant and specific. It uses very simple bag of words features. Here's how it looks like in practice. Now, green on the rubric means good, red means bad. So you see that most of this student submission is good. So we calculate an internal score for this rubric, and then we generate a tip based on that rubric score. So this is mostly good, except for this last part. How would you improve it? Okay. On the other hand, if students have just started, then we would say, what is the first thing you would suggest to improve this work? And there's a number of things in between. You can see the paper for that. We manually coded the feedback that students got after using these hints. And we saw that 81% of students got feedback that we consider actionable. OK. The other thing that we found, just by giving people simple hints, is that we can create somewhat large changes in behavior. So without hints, we notice that students tend to focus on the author of the work and what is good about it. These are the top few n-grams in our corpus of comments. And we see things that like, I think you are, or I wish you good luck, and so on. Or I hope you have a nice day was actually very common. So with hints, on the other hand, students change the locus of attention and focus more on the work itself and what could be better. So they're more likely to say things like, I think you should make this change, or you need to do something, or your work could improve by. So, of course, this is a hinting system. It doesn't always work. Here is one student who complained about it. You want to write some comments, but you don't know what you could have done better. Well, peer study can only tell you what kinds of comments to write. It is still peer feedback. Okay? So students have to apply their own thinking and interpretation. Okay. So together, we've got a system which gives students fast feedback, and we've created a hinting system which nudges people to write more actionable feedback. Now we want to know, does this fast action-oriented feedback improve course outcomes? In this case, final performance on that piece of work. And to find out, we ran a small-scale experiment in the medical education class on the edX platform. And it had 3 conditions. It was a between subjects experiment. So the first condition was similar to what we see in most classrooms today. You submit one final piece of work. You get grades and feedback together. There are no opportunities for revision. The second condition is what you would see, I jokingly say, the enthusiastic TA condition. So you have a small classroom, and you are allowed to revise any number of times, and your TA stays up every night and gives you feedback within 24 hours. In this case, we gave feedback exactly 24 hours after a student submitted. Okay. And the last condition is the early feedback condition. People are allowed to revise any number of times, and Peer Studio provides some feedback as soon as possible. The median student got feedback in less than an hour. All right. In our results, we see that the fast feedback condition improves grades by 4.5% compared to the no feedback, no revision condition. Interestingly, we also found that our early feedback, but delayed by 24 hours condition, had grades which are statistically indistinguishable from having no revision opportunities at all. One reason why this is because when we looked at the comments that students write when they're revising their own work, they tend to reference the comments that their reviewers made much more frequently when they get them quickly. If you get feedback a day later, you've already made up your mind as to what you're going to change. Okay. So you can also see where this kind of revision has the largest benefit. So this is a histogram. The grades are on the x-axis. And I'm comparing the no revision, no feedback condition with the fast feedback condition. And the histogram on the left-hand side looks more or less similar, so let's hide that and focus on the right. And what you see here is students who had work which was mostly good had the opportunity to revise it and make it really good. So the opportunity to revise and get fast feedback changes good work into great work. So you see that more people in the fast feedback condition had a perfect score. So we built this system for large online contexts. And it's been used in online classes, both on the Coursera platform and on edX. But you've also seen that these tools are now being used in in-person contexts as well. So these are classes across 3 different universities who have used it for a wide range of topics. The way it is used in most in-person contexts is you have peers who give each other fast incremental feedback for early work, and you have the TA who performs final grading. So essentially, instructors are using the system to provide students an opportunity to revise something that they couldn't do with just using staff resources. So Peer Studio, again, is a fast revision-oriented feedback system, and it improves course grades and creates these new opportunities for teaching in the in-person classroom. Again, it is open source, and we have a hosted version available at this URL. I did not speak about the motivational aspects of how do you motivate students to give feedback quickly, how do you get them to give good feedback, and that's in this paper here. Yeah?
How do you know that the students aren't learning the answers?
Aren't learning the answers?
Yeah, so I mean, an example of a problem you would have in any course you might teach is that if the students start sharing their homework with each other, that they're essentially copying the answers from each other.
Yeah.
And that represents the improvement of the grade.
Yeah, I think that's a good question, and that's related to the plagiarism question somebody else asked here. So let's actually club both of those questions and take them at the end. Is that fine? Because I want to give you a good answer, not just breeze through it. OK. So so far, we talked about 3 systems: peer assessment in a global online sense, diverse discussions, and feedback for revision. While I've been doing this, other researchers have also adopted some of our insights, and we've seen papers use peer assessment both in the educational sense as well as to create systems for crowdsourced quality control. Many platforms also now have peer assessment systems. I spoke with the guys at edX, and now Khan Academy also uses a similar train and assess model. In the latest development, Coursera now has an on-demand platform for their classes, and it draws on many of the ideas that are presented to you today in Peer Studio. So that was my work so far. I wanted to speak about what I want to do in the future. And one way of looking at my work is to take this view of learning as something that transforms novices into experts. And we've seen traditionally how it's done with deliberate practice. Students revise, they get feedback, they keep improving. And the traditional way of doing it is with the help of a coach. Over the last decade or 2, we have seen intelligent tutoring systems which have enabled more students to do deliberate practice in domains like mathematics. What this talk shows is how we can broaden the domains for deliberate practice to more creative work and more open-ended work. But all of this is still along one dimension, getting students from being a novice in one domain to being an expert in the same domain. But if you look at some of the most interesting jobs that we have created over the last 10 years, they are jobs that did not exist in the decade before. So we have this opportunity actually to help students learn across domains and learn all through their life. So what I want to do in future research is enable people to become adaptive experts who take what they know in one domain and use it to become experts in other domains. I want to give you 3 concrete question/examples of how this might work. So the first is, can we create systems that are explicitly designed for transfer? So far, we teach classes as well as these systems are built in a way that are isolationary. So you think you're taking only a design class at the same time, but you're taking a design class and a machine learning class at the same time. Could we have opportunities for students to transfer what they've learned from one class to another? And could we scaffold that transfer using tools? That's one question. Another is, could we provide everybody on-demand mentorship? Mentors are so great if you find them, right? And finding good mentors is hard. And even when you find good mentors, their perspective is limited. Could we create a system for distributed mentorship? So you have multiple mentors with different perspectives, but who are still attuned to your needs. And finally, both of these talk about, in some sense, the novice end of the spectrum. But experts need help too. Every undergraduate I've worked with speaks about how everyone asks me, what is a camera-ready paper, right? And it's such an arcane terminology. And it's a symptom of a system which is somewhat slow and too insular for today's world. So could we create peer processes which help researchers ideate, collaborate, and ultimately disseminate results more efficiently? In doing my work so far, I've had great advice from great advisors across many departments, CS, education, cognitive science. We've also had the opportunity to work with students across 4 departments and with companies big and small. And in all of this work, I've come to the realization that if you want to truly make progress, you've got to work across domain boundaries. And that's one reason why I'm really excited to be here at Washington. So in closing, this was about structuring peer interactions for learning at scale and how we can create novel educational opportunities by using scale, diversity, and interactions as computational resources and design opportunities. I spoke a little bit about future, and I'm happy to take questions now. And feel free to reach out to me by email afterwards. Thank you.
So we'll take questions now, and I think we have a couple already teed up.
Yeah, so the plagiarism issue. The reason why I used Picasso's sketches is one of the things he said was, good artists copy and great artists steal. And that is what we want people to do, right? We don't want to sequester people so that they never get good ideas from anybody else. What we want to do is, in some way, help students gain ideas from other people, but adapt them so that they become their own ideas, right? So I think that is an opportunity for what systems could do in the future. For instance, by showing students the right kinds of examples, which inspire them to copy in a more intelligent way. When it comes to explicit plagiarism in this, I'm sorry, your question was?
I can say it in a different way.
Yeah.
You could ask the question, after having done this process of practice, are they better at subsequent exam-like questions where they don't have any access to what other people have said?
Yeah.
What you're really after, presumably, is some evidence, not just that their grades are better, because that's just saying, hey, they're participating in the system, they're benefiting from getting the answers from everybody else, but rather also that they're learning more. And it seems like potentially you have the problem of your outcome being polluted by the process that you're measuring.
Yeah, you're right. So one thing that we have, so one problem is that we are using peer feedback for both final assessment and initial, right? And what we have done in this case is we had staff actually assess each work in order to give results which are more valid, right? In this case. But also, the reason why I'm showing you grades in this talk is because they're an ecologically valid measure. Students in classes have grades. But if you look at the papers that I've mentioned, we also look at more behavioral measures. For instance, do students persist for longer is something that Dan asked about. Or do students persevere when they get something wrong to begin with, right? So we also look at measures like that, and they're in the paper. Yeah.
All right, so while people are thinking of questions, I have one. So you looked a lot at things that I'd say build off the metaphors of in-person learning, so things that you might do in a classroom or a discussion group. Mm-hmm. I'm wondering if your ideas apply to other forms of educational media as well, from like textbooks to simulations or things of that sort.
Yeah, so I think you're right. Many of these ideas are in this context, but I think textbooks are one prime case where they don't need to be an isolated experience. They can be a social experience where people can contribute to it. I was talking to you earlier about how we can have textbooks take a point of view as to how people should be taught, So you can ask students to invent a solution, and then you can reveal a solution to them in a later section of the textbook. I think essentially these are peer processes which embodied in a system that's online. But these are principles that work across media. So you could have a peer enriched textbook, or you could have a peer enriched simulation. So I think they would apply. Yeah, I can only agree with you. Yeah. Yeah?
On the diverse discussion groups, did you compare setting a fixed group that the students, that same group met over and over versus selecting people each time? Group
Yeah, we did. Details are in the paper. The most significant bits, in an online class, have the students drop out in week 6 or so, right? So if you're meeting the same people each week, you'll meet only half the people 6 weeks later. So that's a practical concern. But more importantly, pedagogically, we've seen that if you meet different people, you get a different perspective. So if you meet the same people each week, you're going to get a familiar conversation, but it is less. So I started about how diversity creates these cognitive benefits, because you're meeting people who are unlike you and who you're not familiar with, right? So these benefits are reduced if you have people who are the same week after week.
How did the fixed versus generated selections affect retention?
They did not affect retention. They were, statistically, we did not see a difference between the two of them. Yeah?
About the peer grading and how the diversity, their origin influenced how they grade. Did they know who they were?
No, it was double blind. We had no identifying information. They were picking up on subtle cues. I ran a follow-on experiment where I actually removed some of the linguistic cues by making more of them sound natural English in some sense, rather than Google Translate English. And we saw that that reduced the effect. We also saw that the effect reduces if you revise your rubrics so that they're clearer across the world. So there's that as well. But the effect remains. It remains significant even after you remove these linguistic cues. So yeah, thanks. Good question. Yeah. Did I answer your question about the plagiarism well? Or do you have any follow-ups on that? OK, good.
All right, well, let's thank our speaker.